Hey guys, this is the final question number 5. It is calculate the osmotic pressure of 100 milliliters of 3 molarity calcium chloride at 37 degrees Celsius. So this one's going to require a little bit of math, and if you haven't seen this before, you might be scratching your head, but we're actually given a lot of information. So what you have to really remember for this one is the equation for calculating osmotic pressure. So that equation is going to be I like to call this not pi. That's going to be osmotic pressure, right? Equals I, and I is going to be our Van't Hoff factor from the last video. Van't Hoff factor. Okay. The next is going to be it's not pi equals I. M, right? Sorry, M is going to be, and that's going to be our molarity, which you can see right here that we have. So that's molarity. And we're not quite done yet. We're getting there. R is going to be a constant, and that constant is going to be equal to 0.0821. And finally, we're going to have T, where T is the temperature, and we're going to want that temperature in kelvins. Temp. Kelvins. Okay, so we already have a lot of information here. We don't know what not pi, our osmotic pressure, is yet, but we can figure out I just by looking at the molecule that we're working with. So based on what we learned in the last video, we have this calcium chloride. Well, when we essentially when we put it in a solvent that breaks it into its constituent ions, we have 2 chlorines, right? There's a 2 right here, and then 1 calcium. So 2 plus 1 equals 3. So our I is going to equal to 3. Well, we already have the molarity. It was given to us, so we can say that M is equal to 3. We know R, once again, that's a constant equal to 0.0821. And T is our temperature in kelvins. Now, they give us a temperature in degrees Celsius, which, essentially a lot of problems are going to give you degrees Celsius, and, you have to be able to convert that to kelvins. But that's really easy to do. We just take our degrees Celsius and add 273 to it. So let me do this real quick, plus 273, right? So that's going to equal 310 degrees Kelvin. So now from this point, it's kind of just plug or play. So let's go ahead and do this. We'll work this all out. So we know that I is equal to 3, and we know that M is also equal to 3, and we know that R is going to be equal to 0.0821, and that our temperature is going to be equal to 310 degrees Kelvin. So let's go ahead and plug that into the calculator. It was 3 times 3 times 0.0821 times 310. And we can see that our answer for osmotic pressure, not pi, is equal to 229.059, and that's going to be in atmospheres.